conductimetry, polarography, micrometry, ma'am. Potentiometry, we can analyze the millivolt, like that.
Say about quality assurance.
Quality assurance guidelines, calibration, validation, regulatory aspects, ma'am.
Okay. Okay. Thank you.
Thank you, ma'am.
Next. Next person. Joy John. Give your answer on electrochemical methods and quality assurance. Make it fast. Joy John. Okay, Johnson.
Hello, ma'am. Hello.
Okay, proceed.
Ma'am, in electrochemical methods, there are three methods that are potentiometry, conductometry, and polarography. And in quality assurance, the guidelines are given by GLP, ISO 9000, TQM, ISH, ICH. Then the regulatory aspects are regulatory bodies and patents and copyrights.
Patents.
Then
what is the other part of quality assurance you are going to learn?
Validation and calibration.
Okay. Okay, thank you. Shall we start the today's class? Thank you, Joy John and Saktivel.
Thank you, ma'am.
Now let's move on to the second unit in your syllabus, that is Introduction on Chromatography. It is nothing but separation techniques. And that we'll see the introduction part of chromatographic analysis. Okay. So what is chromatography? It is derived from the Greek word called chromatos. Chromatos means color. Graphos means written. What is chromatography generally is the separation of mixture into individual components using a stationary phase and a mobile phase. So what is chromatography? Chromatography term is derived from the Greek word called chromatos. It is nothing but color. So color writing is called chromatography. Okay, graphos means written. Writing in the form of color. So you will be getting a color writing compound or your compound will be located as a colored zone over stationary phase. Okay. So that is called as chromatography analysis. So chromatography is nothing but the separation of mixture. Mixture will be having two or more compounds. Yeah, so they will be separated into individual components. Individual means from mixture it will be separated into individual components using two phases. One is stationary phase, another one is mobile phase. Stationary means stable phase. It is not movable phase. Where mobile phase is movable one. Okay, where separation is going to take place on stationary phase and mobile phase, between these two phases. So both the phases will be in contact while the separation occurs. Mobile phase will be moving over stationary phase for the separation of mixtures into individual components. Thereby we'll be getting chromatographic writing, means color writing you will get on the stationary phase surface. So that is called chromatography. Next is, according to IUPAC, what is the definition for chromatography? IUPAC is nothing but International Union for Pure and Applied Chemistry. It defines chromatography as separation process involving separation of mixture of components. This is the separation process involving separation of mixture of components of a sample distributed between two phases. What are the phases? Stationary phase and mobile phase. One of which is stationary while the other moves. So this is the definition for chromatography. Generally, mixture is isolated or separated into individual components between two phases, stationary phase and mobile phase. What are the two phases and two principles? Commonly in chromatography, we will follow two phases and two principles. What are the two phases? Stationary phase and mobile phase. What are the two principles? Adsorption and partition coefficient. So what are the two phases? Stationary phase. What will be the nature of stationary phase? That is non-movable phase. Stable phase it is. Maybe solid. It may be solid or liquid, which may be supported on a solid. Liquid may be supported on a solid. Okay. Either it will be solid or liquid, which may be supported on a solid. Non-movable phase means it would have been a solid substance. Liquid is movable, but we can make liquid also non-movable by means of coating over the solid surface. Okay, or a gel can be used as stationary phase, or it may be packed in a column or separated as a layer or distributed as a film. In column chromatography, the material will be packed in a column, where in thin layer chromatography, we'll be making this stationary phase compound as layer. Okay. For planar, it will be like a plain surface. Stationary phase will be plain surface. For columnar, it will be in column format. Stationary phase will be filled in the column. Okay. So this is about stationary phase, which is used in chromatographic separation. So it may be of either solid or liquid, which may be supported on a solid. Liquid may be supported on a solid, or merely we can use solid, or a gel. These three type of compounds can be used as stationary phase. Okay, it may be packed. The stationary phase may be packed in a column or as a layer. In column chromatography, it is packed as a column. In thin layer chromatography, or what?
Ma'am, Rafi class join பண்ணோம் ma'am. நீங்க allow.
Okay, very second. Okay. Who is left? Only 17 members are there. All have joined now. Who is absent, pa? So about stationary phases, it is solid or liquid, which may be supported on a solid or a gel. It may be packed in column or a layer or distributed as a film. This is about stationary phase. About mobile phase, it may be of two types, either gaseous or liquid. Gaseous or liquid. Okay. So movable phase, liquid and gas. Mobile phases of liquid and gas. So these are the two phases of chromatography. For latecomers, we are covering regarding introduction on chromatography. Okay, about the what is chromatography? It is derived from, the term is derived from Greek word called chromatos. It is meaning as color, and graphos as written. So chromatography is nothing but color writing. It is a separation of mixture into individual components between a stationary phase and mobile phase. And this is the definition as per IUPAC, International Union for Pure and Applied Chemistry, defined chromatography as separation process involving separation of mixtures of individual components of a sample distributed between two phases, one of which is stationary and while the other moves. Let's see about two phases and two principles. In that, the first one, two phases. What are the two phases? The separation occurs in chromatography, stationary phase and mobile phase. Stationary phase is of stable phase. So stable phase is obtained by using solid or liquid coated over the solid. Solid or liquid coated over the solid, or a gel, polymeric gel can be used as a stationary phase. It may be prepared either as a plain surface, as a layer, or as a column, or distributed as a film. Okay, so this is how stationary phase, non-movable or stable phase, is prepared for the separation in chromatography. Another one is mobile phase. It is movable phase over the stationary phase. Thereby, the separation occurs from mixture to individual components. So it may be of either gas or liquid. Let's see about two principles. One is adsorption. Note down the spelling AD, adsorption. Adsorption means the sample get adsorbed over the surface of stationary phase. Adsorption, not absorption. So you will be coming across about absorption also under spectroscopic analysis. So remind that in chromatography, what principle we follow? Adsorption. In spectroscopy, we will be following absorption, B and D. There is the difference between B and D. So in chromatography, it is adsorption. It is surface phenomenon. Only adsorption occurs on the surface. Where absorption, it is absorbed inside the sample. Here, sample get adsorbed onto the stationary phase. So it is called adsorption. Another one is partition coefficient. Partition means the sample will be distributed between two phases, that is stationary phase and mobile phase. In between two phases, sample will be distributed equally. That is called partition coefficient. So based on these are this is the main two principles followed in chromatographic analysis. One is adsorption, another one is partition coefficient. So keeping this phenomenon, many principles also are adapted, changing the nature of stationary phase and mobile phase. This is the basic principles of commonly chromatography. Not only column, both column and planar chromatography follows adsorption or partition coefficient principle. Okay. If you will be seeing that in brief under each and every chromatographic techniques. What is adsorption, how it takes place, what is partition coefficient, how it is going to take place. Then let's move on to the classification of chromatography. So till now we have seen definition on chromatography and then about two phases and two principles under chromatography. Let's move on to the classification of chromatography. What are the different chromatographic techniques are there? Already we have seen the broad classification under introduction part itself. What are the two classifications? Columnar and planar chromatography. Column we have seen HPLC, gas chromatography. These are column chromatography, and along with column adsorption chromatography, where planar chromatography are paper, TLC, HPTLC. Now we'll see other types of classification. First one is based on the principle of separation. What are the two principles we have seen? Adsorption and partition. If the chromatography follows adsorption, then it is called as adsorption chromatography. If it follows partition coefficient as principle, then it is called as partition chromatography. So first classification is based on the principle of separation. We'll see what is adsorption chromatography. When it is a definition for adsorption chromatography, when a mixture of compounds, that is adsorbate, compounds mean our sample, it is called as adsorbate, dissolved in the mobile phase, eluent. It will be dissolved in the mobile phase called eluent. Mobile phase may be called as eluent. Mostly this term is used in column chromatography. Mobile phase may be called as eluent. moves through a column or stationary phase. So in column, stationary phase will be packed, that is adsorbent. They travel according to the relative affinities towards the stationary phase. So your compound will be moving over the stationary phase along with your mobile phase based on its relative affinities. This is called adsorption process towards the stationary phase. Okay, some sample will be having more affinity towards stationary phase and some will be having more affinity towards mobile phase or less affinity. So based on that, they will be getting separated from mixture into individual components, because all the components are not same. So definitely they will be having different adsorption coefficient, so that it will be absorbed. Affinity towards stationary phase will be varying for each and every compound. So taking that concept, the mixture is separated into individual components under adsorption chromatography. Under adsorption chromatography, whatever sample you are going to separate is known as adsorbate. Mobile phase, what you are going to use is called eluent. Yeah, this eluent term is used in column chromatography. When column or stationary phase you are using for separation, then it is known as eluent. Normal in planar chromatography, it is called as mobile phase solvent only, mobile phase. And moves through a column of stationary phase, that is called adsorbent. They travel according to the relative affinities towards the stationary phase. Clear? So then more affinity, again the concept comes how the affinities towards stationary phase takes place and how the sample travels over the stationary phase along with mobile phase. More affinity towards stationary phase will cause the sample will be traveling slower over the stationary phase. If more affinity, it will get more attached to the stationary phase, so it moves less. So travel slower. If opposite, vice versa, that is lesser affinity towards stationary phase, then it travels faster. So it will be moving along with the mobile phase fast. So stationary phase nature will be for adsorption as solid, mobile phase either liquid or gas. In case we use stationary phase solid and mobile phase liquid, then this is the example for column adsorption chromatography. Examples for adsorption chromatography is column adsorption chromatography, where we use stationary phase as solid and mobile phase as liquid. In gas solid chromatography, gas as mobile phase, solid as stationary phase will be used. For thin layer also solid and liquid. Only for gas chromatography, mainly gas solid chromatography under adsorption principle, will be using mobile phase as gas and stationary phase as solid. Solid, either it will be liquid may be coated with solid or only solid can be used as stationary phase. These are examples of adsorption chromatography. Column adsorption, gas solid chromatography. Gas solid means it follows adsorption principle. Over solid only adsorption takes place. Okay, so that gas solid chromatography it is. And thin layer chromatography, TLC, that also uses stationary phase solid and mobile phase liquid for separation. For column and thin layer, same type of stationary and mobile phase. For gas solid only, we'll be using mobile phase as gas. Okay, understood about adsorption chromatography now? So it is a mixture of compounds dissolved in the mobile phase, moves through a column of stationary phase. Okay, so sample in the form of solution, where we will be dissolving your sample in the mobile phase. Then it travels according to their relative affinities towards the stationary phase. So that based on the affinities and adsorption coefficient, it will be getting separated into individual components. So more affinity towards stationary phase will travel slower, lesser affinity towards stationary phase will travel fast. And when stationary phase used for column adsorption and thin layer is solid and liquid. Mobile phase is liquid. For gas solid is solid and gas. Name itself, it is getting as gas solid chromatography, GSC. It is nothing but gas solid chromatography. Mobile phase and stationary phase used. So let's move on to the next principle of separation. So we are seeing what classification based on the principle of separation, what are the types of chromatography. In that, now you have learned what is adsorption chromatography. Let's move on to partition chromatography. Partition means both stationary phase and mobile phase will be of liquid. You have to remember that partition means partition occurs between two immiscible liquids. So what are the two immiscible liquids? They are two phases, stationary phase and mobile phase. How we can make stationary phases liquid form? We can coat liquid as stationary phase over the solid surface. That's what we have seen here. Stationary phase may be of solid or liquid, which may be supported on a solid. So this category of stationary phase is preferred for partition chromatography. Okay, so when two immiscible liquids are present, that is stationary phase and mobile phase. Mobile phase will be already liquid. Whereas stationary phase, if we make stationary phase also as liquid, then it gives partition principle. A mixture of solute will be distributed. A mixture of solute is your analyzed sample will be distributed according to their partition coefficient. So definitely no two samples will be having same partition coefficient. So according to its difference in the partition coefficient between two immiscible liquids, the mixture will get separated into individual components. Where a mixture of compounds are dissolved in the mobile phase and passed through a column of liquid stationary phase. It also mentions column chromatographic principle. Over a thin layer also the same happens. Here a sample is dissolved in mobile phase and it is allowed to pass through the stationary phase, where the sample, according to its partition coefficient, it is getting separated into individual components between two immiscible phases. Immiscible phases are stationary and mobile phase, two immiscible liquids. If we use the polar form of mobile phase, then it should be non-polar or stationary phase. Then only we will get immiscible form. Okay. Both if we use water or same polarity, then it is of miscible solvent. So we will not get partition coefficient. If we use immiscible only, partition coefficient means definitely it occurs between immiscible liquids. So distribution of sample occurs between two immiscible liquids according to its partition coefficients. It's known as partition chromatographic separation. If the compound is more soluble in mobile phase, then it travels faster. Mobile phase is movable phase. If the sample has more solubility or distribution towards stationary in the mobile phase, then it travels faster. If it is dissolving more in the coating of liquid stationary phase, then it travels slower. So according to that partition separation, the sample gets separated over the stationary phase. So stationary phase here is of liquid that is coated over the solid surface, and mobile phases of either liquid or gas. If gas we use, then it is gas liquid chromatography. Gas, if we use as mobile phase, then we'll get gas liquid chromatography, GLC. This is the widely used chromatography when comparing with GSC, what we have seen under adsorption. Adsorption principle is not widely preferred comparing with GLC. GLC is widely used technique. GC means we will be preferring GLC only, okay, which follows partition principle. And another one is paper partition chromatography. Paper chromatography follows partition principle. So this is another example for partition chromatography, where we use both stationary phase and mobile phase as liquid. In paper also we'll be using stationary phase and mobile phase as liquid. Only in gas liquid chromatography, mobile phase will be gas. In all other chromatographies, both will be of liquid. Column partition also it will be of liquid. Column partition comprises of HPLC, okay, in liquid chromatography. And merely column partition also we can use for isolation. Where for isolation, comparing column partition, we'll be preferring column adsorption chromatography for isolation. Open column chromatography, that is. Where closed column chromatography will be HPLC, high performance liquid chromatography. So this all follows partition principle. Understood, no? So based on principle of separation, what are the two techniques? Adsorption and partition chromatography. Let's move on to the second classification of chromatography based on the modes of chromatography. Modes. What are the two modes of separation? Means normal phase separation and reverse phase separation. Here phase represents stationary phase and mobile phase only. Okay, phase means in chromatography that is stationary and mobile phase. It represents stationary phase and mobile phase. Here, if it is normal, then it is normal phase. This normal and reverse are named according to its polarity. Stationary phase and mobile phase polarity, based on which it is getting termed as or modes are represented as normal or reverse. We'll see what is normal phase and reverse phase mode. What is normal phase separation? Where stationary phase will be of polar in nature. Stationary phase will be polar. Mobile phase is of non-polar. In normal phase, stationary phase nature is polar. Mobile phase nature will be of non-polar. Okay. Non-polar components travel faster and are eluted first. So in this normal chromatography, since mobile phase is non-polar, if the compound is non-polar, then it will be more soluble in mobile phase, that is movable phase, so that it gets eluted faster. Means separated faster. If you are separating polar compounds, then by normal phase chromatography, polar compounds will be more attached to the stationary phase. Since it is polar in nature, it reacts with the polar compounds. Then the elution will be time taken. Since mobile phase is different polarity comparing with stationary phase and the sample, it will take more time for elution in the column chromatography. So that normal phase chromatography will be time consuming for polar compounds. Hence, we will be going with reverse phase chromatography. It is widely used principle under chromatographic technique. Where reverse phase. Since mobile phase is non-polar in nature in the normal phase, it is applicable more for non-polar compounds. So that mostly if you see our drug products is of polar in nature. Okay, we cannot take non-polar drug molecule inside the body, since our body is not filled with non-polar solvent. It is filled with water, that is polar solvent. So mostly we have to design our drug molecules of polar compounds only. According to the polarity only, the components are designed, drug molecules. So which chromatography will be preferred for separation? Reverse phase chromatography, where mobile phase is polar in nature. Here polar compounds will be soluble more and it will be eluted fast. So that reverse phase, RP will be calling RP, HPLC or RP, HPTLC are widely used for drug molecules separation by chromatographic techniques. So less affinity between solute and stationary phase for non-polar compounds, where polar compounds will be retained longer time in the column, that is stationary phase, and takes more time be eluted from the column. If polar components are separated by using NP chromatography, then it will be eluted very slowly comparing with non-polar compounds. Since movable phase or movable phase is non-polar in nature. Okay, understood the concept now? Then this is reverse phase, where stationary phase is non-polar. Exactly. There is reverse of another phase. In normal phase, it is polar in nature. Stationary phase, polar. Mobile phase, non-polar. Normal phase, mobile phase, non-polar. Where in reverse phase, mobile phase is polar. If you remember any one phase polarity, you can remember another. It will be of opposite nature, right? So, stationary phase here is non-polar, mobile phase is polar. You remember better, mobile phase is polar in reverse phase chromatography. If you ask what is the polarity of stationary phase and mobile phase in reverse phase, you can remember that mobile phase is polar in reverse phase. So that it is widely used. So stationary phase will be automatically non-polar, and in normal phase, mobile phase will be non-polar and stationary phase will be polar. So likewise, you can remember the nature of mobile phase and stationary phase in modes of chromatography, different modes of chromatography. So here polar compounds will be eluted first since movable phase is polar. Non-polar compounds will be retained for a longer time in the column since stationary phase is non-polar, where it will be reacting with non-polar compounds more. Okay, and this principle is applicable more in HPLC and HPTLC, high performance liquid chromatography and high performance thin layer chromatography. So this is the second type of classification. So first is based on what? Principle of separation. Second classification is based on modes of separation, that is modes of chromatography, normal phase and reverse phase. Next, the third classification of chromatography is based on the elution. Elution means, I told the mobile phase called as eluent. When eluent elutes out the eluvate, eluvate is called pure sample. If it is eluting the eluvate, then the process involving eluent, eluvate, dissolve, then it is known as the elution process. Okay. For elution process, elution is separating out the sample from the column chromatography. So it is called elution, and this principle mostly applicable for column chromatography elution technique. Where isocratic means, iso means same. So we'll be using same polar solvents as mobile phase. MP represents mobile phase here. It's not a standard short form, just I have mentioned here. You can write mobile phase itself, okay? And there's the full form. Isocratic elution means, same polar solvents as mobile phase is used in the elution process. Eluent used as same polarity, or single polar solvent is used for isocratic elution. Gradient means different. Different polar solvents are used as mobile phase in gradient elution. Different polarity, either non-polar and polar solvent, or both polar with a different polarity we can use, or medium polar and polar we can use. So this is achieved by gradient elution. Okay. So this is the category of two elution techniques. So that chromatography is also called as isocratic chromatography or gradient chromatography based on its elution. Isocratic will be having single pump, gradient will be having two pumps in the instrument itself. In the chromatograph itself, isocratic elution, isocratic means single solvent, single polar solvents we will be using, same polarity, either water, methanol, or likewise same polar solvents, either highly polar solvents or medium polar solvents, same polarity will be using, so that single pump is needed for mobile phase, using mobile phase. Okay, so it will be, instrument itself will be having single pump. For gradient elution, it will be having multiple pumps. That is more than one pump for gradient elution. Since we have to use different polar solvents, minimum of 2 solvents will be using with different polarity. So if we use many different polar solvents, then we can go for tertiary and quaternary pumps for gradient elution. Okay, these are the two types of elution techniques under chromatography. This is the third classification of chromatography based on the elution. What are those? Isocratic and gradient. Isocratic means same polar solvents are used. Gradient, different polar solvents are used. Next, the fourth part is miscellaneous or other types of chromatography. Ion exchange and size exclusion. These two chromatographies are modified form of HPLC. Column is changed according to the separation, principle of separation. Okay. In ion exchange, we'll be using ion exchange resins, wherein size exclusion will be using gel for separation. Okay. So what is ion exchange chromatography? Here ion exchange resins are used. These resins are insoluble in water. Insoluble ion exchange resins are used as stationary phase. For exchange of cations, cation ion exchange resins are used. That is, cation exchanges are used. For exchange of anions, anion exchanges are used. So stationary phase will be decided according to which ion you are going to separate, either cation or anion. This why you need to read ion exchange chromatography means, Your all biological fluids will be having proteins. Proteins may exist in both the form, cationic form and anionic form. So we can better isolate or elevate or separate protein molecules, mixture of protein molecules or individual protein molecules by means of ion exchange chromatography. So that only you need to learn the concept of ion exchange chromatography. In brief, we'll be discussing under the particular topic. Then second classification is exclusion chromatography. Exclusion means that is elution only, here called as exclusion. Based on size, molecular size, it will be separated based on molecular size, not based on absorption or partition coefficient. It is based on molecular size. Whatever sample you use, according to its molecular size, separation occurs. So separation of sample components take place according to molecular size. So it is called size exclusion chromatography. What are the techniques developed on exclusion principle is gel permeation. That is nothing but gel filtration or affinity chromatography. So that follows exclusion principle. And another one is sieving separation. Sieving also based on molecular size, particle size, right? Sieving occurs. So based on particle size, sieving separation takes place. For both the purpose, we'll be preferring stationary phase as gel, polymeric gel, or it will be having pores. Between the pores, it will be getting sieved or separated from the mixture. Your component will be getting separated from the mixture. So this is known as exclusion chromatography or size exclusion chromatography. So these are the different categories of chromatography. So first, summary and classification of chromatography. First one is based on principle of separation. So what are the two principles? Adsorption and partition coefficient. What are the two modes of separation? Normal phase mode and reverse phase mode, NP or RP. RP is widely used since mobile phase is polar in RP. Then based on elution, isocratic and gradient. Another based on exclusion principle, ion exchange and size exclusion. Okay. So with this, we'll complete today's class. So you have learned about definition today, definition and classification, and the chromatography. In the next class, we'll see the history of chromatographic development. What are the older techniques developed? What are the modern and modest recent techniques developed? Developed chromatographic separation. We'll discuss in the next class. Thank you all for patiently listening. If any doubts, you can clarify now. You can clarify your doubts if you have. Hope you all have marked your attendance. If every concept is clear, then we'll meet in the next class on Thursday. When you people are coming directly to college? On Wednesday or some other day?
Don't know, ma'am. தெரியாது ma'am.
இன்னும் தெரியல. ஓகே ஓகே. நம்ம இப்ப டிஸ்கஸ் பண்ண கான்செப்ட்ஸ் புரிஞ்சுதுங்களா? If then we'll leave the meeting now. Can anyone respond?
Understand, ma'am.
No doubts, ma'am.
Okay. Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am. Thank you, ma'am.
Thank you for your kind cooperation for all the.